Alrighty, so we did a lecture today that basically took the first 15 vocabulary words and we explained them by applying them to number 9, the free body diagram. We're going to do a simplified free body diagram for the day where we only have 2 force vectors. That's what you need to know for the exam. Okay, you need to know how to do that for sure. Alright, so let's go ahead and look at it. We're working on force. Of course, you know the symbol for force is F. The unit for force is N, the Newton. Okay, so Newton, because Isaac Newton is the one who worked with force a lot. How do unbalanced forces change motion? We end up with a change in velocity. This is acceleration, right? Change in velocity is acceleration. Okay? The system is just where the forces are acting. Contact force is touching to push something, right? So a force is a push, a pull. Okay, so a contact force is an actual touch, right? You have to physically touch. Field forces, they do not physically touch. This is going to be gravity. It's like the gravity, electromagnetic force, and the strong and weak nuclear forces. Okay, we don't need to worry about those too much right now. Okay, but these are all field forces. An agent, this is who does or what does the pushing or pulling. Okay, what does the push or pull? Okay, a free body diagram are these guys. It's where you make like a box and you show the forces. Okay, that's what that is. We're going to draw free body diagrams and we're going to combine the forces. This is also called 11 and 12 are the same thing, net force, and this is the equation for net force right here. Okay, net force is you add up the forces, the sum of the forces, summation of the forces. Okay, so that's what that is. What's the effect of an imbalance of force? A change in velocity. Okay, or you create acceleration. What is the relationship between acceleration, force, and mass? So A, F, and M. This is the relationship between A, F, and M. Okay, this is also called Newton's second law. Okay, this is Newton's second law. Newton's second law and this equation are the exact same thing. Okay, this is acceleration is created by a force divided by a mass or opposed by a mass. Okay, so you need to know this. Now let's go ahead and take a look at how to work these out. Okay, all right. So if I have a system, so here's my system. Some agent is pushing with 6 newtons of force to the right, and I am opposed by 6 newtons of force to the left. So this is my force oppositional this way, okay? All right, so what I have to do to solve for acceleration and force net, we always start with force net. Start with the force net, okay? I'm going to figure out my force net by adding up my forces. Okay? You remember when we had vectors in the first chapter? I pick a direction to be positive, and the opposite direction is negative, right? So let's actually do the summation of forces. Summation of force is equal to force 1, 6, plus force 2. It's negative 6, right, because it's going the opposite way, negative 6. And I don't really need to write plus negative, right, so I can just rewrite it as 6 minus 6. So what is the sum of my forces, or the force net? 0 newtons, right? Cool. Now, let's go ahead and come back and let's do the next one. This one, I have my summation of forces. What's the net force? It's positive, negative, right? So I have 6 positive and I put minus 4. So what's my sum of the forces? 2 newtons to the right. Okay, to the right or east, right, just make sure to put the directions. The force net 2 newtons east, 2 newtons east, right, or let's do this one. I have a couple things going on here. Let's go ahead and just look at this. We're going to get my y-axis. What's the sum of the forces? Let's say this is positive, this is negative, right? So I have 10 minus 10, which means I have 0, which means I'm not going to accelerate in the y-axis. I'm at equilibrium in the y-axis. If you have 0 newtons, that is equilibrium. You need to know this. This is the fact everybody's going to forget. It's like, remember, I'm always like, half of y'all will forget this tomorrow. This is the one. 0 newtons of net force. If your net force is 0, you have equilibrium, which means you're not going to accelerate. You're going to move constant. Okay, and the x-axis, though, look at this, the sum of the forces. This is going to be positive. This is going to be negative. Ready? 9 minus 3. So what do I get? 6 newtons. 6 newtons to the right. Okay? Okay. Let's go back up here. Now, we figured out the net force. Now we can figure out the mass, right? We figured out the mass. The mass is 2 kilograms. 2 kilograms. We kept it 2 the entire time, right? 2 kilograms. Here we go. So our equation for acceleration is the force net divided by the mass. We figured out the force net by adding up the arrows, right? Opposites subtract. So let's see. We have 0 divided by 2. And that's going to get us 0 meters per second squared. 0 meters per second squared. And that makes sense because if I have no force, that means I can't accelerate, because what was an imbalance of force? A change in velocity. My forces are balanced, so I have no change in velocity. Okay? No change in velocity. I have a constant velocity. I have equilibrium. Okay, I have equilibrium on my x-axis. Okay, look here. This time, am I going to have acceleration? Yes, because I have a net force. I have a net force that is not 0. So let's actually do it. Okay, so remember, it's force net divided by mass equals 2 over 2. So what's that? My mass is 2, right? 1. My acceleration is 1 meter per second squared to the east. It's always going to be the same direction. See that? Same direction. Okay, here we go. What's my force net? 6 newtons to the right. So can you guess which way the acceleration is going to be? Even if I get it wrong, I know it's to the right. These are always the same. Okay? So let's see. I do force net divided by mass to get my acceleration, right? That's the relationship between A, F, and M. So plug them in. I would always write this equation because people are messing up and they're putting mass on top and they're dividing by 6, and you got to be careful. So look, force is 6, so I plug it in the top. Mass is on bottom, so I get the mass, and I plug it on the bottom. So I get 3 meters per second squared. Cool? Practice these.